Hello everyone, welcome to my YouTube channel Easy Way to Learn. I am Shelija and today we'll discuss soaps and detergents. So let's get started, remain focused and follow the lecture. See, soap molecule, if we see a single soap molecule, it is represented by a circle and a zigzag line that you see here. See, this is one soap molecule. So what does this soap molecule or this structure indicates? See, chemically, if you see, this zigzag line is representing carbon chain. So this is basically CH3, CH2, CH2. So this is long carbon chain of carbon 17, that is 17 carbon chain is present here, CH2, and then this point is basically representing CH2 and the free end represents, this free end represents CH3. So basically each point is representing CH2, CH2, CH2 and there is a long carbon chain. This finally ends as, or we may write it like this, CH2, then COO negative and sodium positive. So this much part is basically the hydrocarbon part, and Na, the ionic part is the this much part, Na. So this circle that is represented here is basically the carboxylate ion attached to sodium ions. See what happens, this much part, that is the hydrocarbon part, is called hydrophobic. So the word is hydrophobic. Hydro means water and phobic means fear. So this part will try to remain away from the water. And this ionic part is called hydrophilic. Hydrophilic. So again, hydro means water, philic means love. So this part will tend to remain towards the water. See, there is one more name for this hydrophobic part. It can also be written as lipophilic. So it is hydrophobic, that is fearing, it has fear from water or it will tend to avoid water, but it is highly soluble in lipids or oils. So it is lipophilic. In terms of lipids, we will call it lipophilic, and this will be lipophobic. So in class 10th syllabus, you have to just remember it in terms of hydro, that is in terms of water. But you must have little bit more understanding, because to solve assertion reason type questions, if the question is in the form of lipo, that you must understand this hydrocarbon part dissolves in oils or organic solvents. So lipids or the oils are organic solvent, while the ionic part will not dissolve in lipids. So it is lipophobic. Next we come to the micelle formation. See, most dirt is oily in nature. So there are keywords that you must always remember while writing your answer. So one important thing is, most dirt is oily in nature, and you know oil does not dissolve in water. So soap molecules are basically sodium and potassium salts of long chain carboxylic acids. So basically this soap is sodium. So in place of sodium, it can also be potassium. So Na, say Na, or it is replaced by potassium. Okay, so soaps, how you are going to define soap? So soaps are sodium or potassium salts of higher fatty acids or long chain carboxylic acids. So this is the definition of soap. See, the ionic end of soap interacts with water, that I just explained, while the carbon chain interacts with oil. So it is water fearing part, but it dissolves very easily in oils or fats. See, soap molecules thus form a structure called micelles. So next we see what is micelle. So this is the structure of micelle. See, where one end of the molecule is towards the oil droplet while the ionic end is outward. So if we understand what is micelle, see, dirt is basically oily in nature. So the soap molecules, when cloth having dirt is soaked in soap or detergent, the ionic part will tend to remain towards the water, while the hydrophobic tail will tend to dissolve in this oil. So see, this is oil particle, and soap molecules will attach themselves in this manner. That is, this hydrocarbon chain will get attached to the oil part. So if all the molecules will attach in this manner, circular manner, so the ionic part is facing the water surface, while the hydrophobic part is attached to the oil. See, this way. So this cluster is called micelle, and just by giving a little friction, this micelle that is attached to the oil particle will come into the water. So this will now become the part of water, and it will get detached from the cloth or any dirty cloth having these dirt. Okay. See, this forms an emulsion in the water. Soap mixes thus help in pulling out dirt in water, and we can wash our clothes clean. So once again, dirt is basically the oil particles that are attached with the dust. So oil and dust will make the clothes dirty. See, dust will be obviously washed off by water, but the oil particle will not be washed away by water. So we need soaps. So the oily part, the hydrocarbon end of the soap will attach to the oily part, and the ionic part will remain in the water. So just by simply scrubbing the clothes, that micelle gets detached from the cloth, or the micelle particle that is holding on to the dirt particle will get detached from the cloth and will now become the part of water. So thus the clothes get clean. So here also we can see the action of soap. See, this is oil or dirt. See, this is oil or dirt that is present, and the soap molecules, this is hydrophilic part and the tail is hydrophobic. So the hydrophobic part will get attached to the oil. See, the hydrophobic part is getting attached to the oil particle, and finally it forms the structure, this structure which is called micelle. Okay. See, one more question is asked here. See, can you draw the structure of micelle that would be formed if you dissolve soap in hydrocarbon? So this is very important. Uh, when soaps are dissolved in hydrocarbon, we get reverse micelle. So reverse micelle, see, reverse micelle, this is just the reverse of the micelle structure. In case of reverse micelle, that is, now the soap is dissolved in hydrocarbon. So I'll write it here. Soap dissolved in oil or hydrocarbon. Oil or hydrocarbon. So the question is asked, can you draw the structure? Yes, the structure will be just the reverse. Now the soap molecules are surrounded by oil or hydrocarbon. Let's write it oil here for simplicity's sake. So now this tail part is lipophilic or hydrophobic. So this part will easily dissolve in oil. So this will be the outer surface, form the outer surface of the whole structure which is in contact with the oil particles. And the ionic part will be on the inside because it is now hydro or in terms of oil we can say it is lipophobic. So it will tend to avoid oil, so it will cluster in the center. Hence the name reverse micelle. So whatever the structure you get in water, reverse you will get in the hydrocarbon. So this is the structure of reverse micelle, or simply if you have to draw, you will draw in this manner. See, this case the ionic end will be towards the center and the hydrocarbon chain will align towards the outside. So if this is the structure, you will call it reverse micelle. So it is surrounded by, here it is surrounded by oil. Now next we'll see see, now this is something important. See, have you ever observed while bathing that foam is formed with difficulty? See, with difficulty, an insoluble substance called scum remains after washing with water. See, now here you must understand what is hard water and soft water. See, we call water as hard when there are calcium and magnesium salts present. Large amount of calcium and magnesium salts are present in water. So if water is containing large amount of these salts, so the water is called hard water, and it is not very easy to form foam or lather. So if we are using hard water for bathing or washing, so it won't form lather. Lather means झाग. झाग नहीं बनता है. So with hard water, soaps don't form lather. This is caused by reaction of soap with calcium and magnesium salt, which causes hardness of water. So you must remember water containing lot of calcium and magnesium salts are called hard water, and if these calcium and magnesium salts are present in small quantity or absent, it is called soft water. So this problem arises with hard water, that scum is formed. Insoluble substance, scum is formed, which remains attached to the cloth. That is, dirt will not be removed. See, this problem is overcome by using another class of compounds called detergents as the cleaning agent. So, in some places where you get hard water, so instead of using soap, we use another compound which are called detergents. Now, what are detergents? Detergents are generally sodium salts of sulfonic acid or ammonium salts with chloride or bromide ions. So, you must remember what are detergents. See, so detergents will look like somewhat like this. They will also have a long hydrocarbon chain, and the ionic part will be different. So instead, okay, the detergent the formula for the detergent or the chemically it looks like this. This is sodium salt, sulfonate salt basically, or you can say this is sodium sulfonate salt. So detergents are basically sodium sulfonate salt. You don't need to remember the exact composition or exact formula, but you must, for understanding that it resembles like this. Carboxylic end is replaced by the sulfonate end. So it is basically made from sulfonic acid or ammonium salts with chlorides or bromide ions. Okay, both have long hydrocarbon chain, so this part will be same. So the hydrocarbon part remains same, or we call it hydrophobic part. Remains same, but the ionic part is different. See, both have long hydrocarbon chains. The charged ends of these compounds do not form insoluble precipitate with sodium and magnesium ion in hard water. So detergents are used in case water is hard because it won't form the precipitate or scum. Thus, they remain effective in hard water. Detergents are usually used to make shampoos and the products for cleaning clothes. Okay. Next question can be asked, what is difference between soaps and detergents? So first is the composition. Soaps are basically sodium salts of carboxylic acid in long chains, whereas detergents, detergents are sodium salts of long chains of benzene sulfonic acids. The formula that I wrote. Another is soaps are biodegradable while detergents cannot be biodegraded. This is second point. Now the third point, soaps have a relatively weak cleaning action while detergents have strong cleaning action. So you can add detergents have a strong cleaning action. Okay, soaps will form lather with soft water, or you can write soaps do not form lather with hard water, whereas detergents form lather with hard water. Or they remain effective in hard water. That is, they have good cleaning action even in hard water. Okay, now let's see these questions. Would you be able to check if water is hard by using detergent? No, we won't be able to check because detergent will form lather with both hard water and soft water. So we would require soap. So people use variety of methods to wash clothes. Usually after adding the soap, they beat the clothes with a stone or beat with a paddle, scrub or brush or agitate in washing machine. Why is agitation necessary to clean clothes? This is necessary because micelle that is attached to dirt needs to be removed from the cloth. So by giving a little friction or by scrubbing it, we remove the micelle particle which is holding on to dirt. So from the cloth surface, it will come into the water. Hence, the cleaning action is performed. Hope you understood the topic well. Please like, share, and subscribe. Keep practicing, and best of luck for your board exams. Thank you so much.